Hello kids, how are you? Good morning again. Um, my name is I am Nirtayana and currently I am available at the Hamlet Tuition Center Brahmatol Kathmandu and Kumudini Secondary School Kalimati Kathmandu. Dear students of grade 10, we have been studying about energy, isn't it? Sorry, grade 9. Dear students of grade 9, we have been studying about energy, work, energy and power. And in our last class we discussed about types of mechanical energy or types of energy on the basis of simple mechanics. Okay, and based on simple mechanics all types of energy are divided either as kinetic energy or potential energy. Okay, all types of energy can be categorized as kinetic energy or potential energy. Okay, let's revise this. If an object is in state of motion, then that object possesses a form of energy due to its speed, which is known as kinetic energy. And if an object is either in stress or at certain height, then it possesses a form of energy which is known as potential energy. So now the question is, does an object only has kinetic energy or only has potential energy? Yes. The thing is, we will study later that energy generally convert or transform from one form to another form. Okay. Now my question is, if suppose an object, this is an object, yes, if an object is simply moving forward, okay, if an object is moving forward, then if an object is moving forward, then which type of energy does it possess? Definitely we all know that it possesses kinetic energy, isn't it? It possesses kinetic energy. Yes, and you know the formula of kinetic energy, it is equals to half of m into v square. Yes, kinetic energy is the function of mass and velocity. Okay, increase in mass increases kinetic energy in linear fashion, whereas increase in velocity increases kinetic energy in square function, with a square function. Okay, that means if velocity is increased by 2 times, kinetic energy increases by 4 times. Yes, this possesses a kinetic energy. But what if after moving a certain distance it suddenly stops? What if it stops suddenly? What happens to its kinetic energy? Where does that energy go? Okay, where is that kinetic energy? My question. Where is that kinetic energy? Where does it go? Well, literally that kinetic energy is converted into potential energy. Okay, when object is moving it contains kinetic energy, but when it stops it happens to contain potential energy. Okay, so let's discuss it like this. Suppose this is ground level, okay, and there is a building. Yes, ground level, there is a building, and at the top of building you hang, there is a ball. Okay, at the top of building there is a ball, and let's say that it's the height of building is okay, okay, let's say the height of building is how much? Okay, 20 meter. Okay, let's say height of building is 20 meter. Okay, and then mass of this object b, mb, okay, 5 kg. Okay, mass of this object b 5 kg. Okay, then if it is just standing still at this height, then which energy does this ball possess at this height? You know, it is potential energy, isn't it? Its potential energy is, we know the formula mgh. Yes, so value of m, okay, my okay um okay, value of m is 5 kg multiplied by value of g, let's take it as 10, and value of h is 20. Okay, so what is its potential energy at this height? Let me calculate it. 2 1 2 2 2 5 ja 10 0 0. Okay, 1000 joule. Well, the ball at this height has a potential energy of 1000 joule. And what about its kinetic energy at that height? Ke equals to mv square by 2. Okay, mv square by 2. Now it definitely has certain mass, isn't it? 5 kg. But is it moving? It is not moving, so its velocity is 0 square divided by 2. Yes, so in overall equals to 0 joule. And overall it has 0 joule of kinetic energy. Yes, okay. What I'm trying to tell you here is, when this ball is at certain height, it has 1000 joule of potential energy, but it definitely does not have any kinetic energy. Okay, it has 0 joule of kinetic energy. And when it starts to drop down, okay, when it starts to drop down, it moves. Yes, it starts to drop down means it is under motion. And let's say after 2 seconds, t equals to 2 seconds. After 2 seconds, what will its velocity be? Well, if acceleration is 10 meter per second square, then in first 1 second its velocity will be 10 meter per second, and in 2 seconds its velocity will be 20 meter per second. Yes, and at that time what height will it gain? Okay, in one, its velocity is 10 meter per second. Okay, let's say just 1 second, let's not do it at 2 seconds. Okay, 10 meter per second. Its velocity is its acceleration is 10 meter per second, means in 1 second how much distance will it cover? S equals to ut plus 80 square by 2. Do you remember this numerical from Subat? Okay, u, initial velocity 0, yes, and t is 1 second plus a 10 multiplied by t square, t 1 second, yes, 1 square, and divided by 2. Okay, this gives us s equals to 0 into 1 0 10 1 the 10 10 by 2 5. Okay, so 5 meter, it covers 5 meter height. Okay, after 1 second it covers 5 meter height. That means this object, look here, this object, it has fallen up to this height, isn't it? And it has within that time it has covered 5 meter distance, which means at what height is it now? Okay, okay, you know that now it is at a height of 15 meter, isn't it? Okay, now at this position, let's calculate its potential energy and kinetic energy. Okay, at this position. Okay, uh, okay, and previously, okay, you do not need to take note on this one. Okay, this one is only for understanding. Okay, here, since it is at 15-meter height, what will be its its potential energy? What's happening? Okay, uh, it is at 15-meter height, means 15 times 5, 75. Yes, 75 and 750. 15 5s are 75, 0, 750. Okay, it has 750 joule of potential energy. What about its kinetic energy? M into v square. Its velocity, you have calculated its velocity to be 10 meter per second. Yes, 10 square by 2. That means 10 square 50, 100, 100 by 250, 50 into 5, 250. See, when it is at when it was at the top of building, it has kinetic energy of 0 joule and potential energy of 1000 joule. And when it is it starts to fall at certain height, then its kinetic energy is 250 joule. Its kinetic energy becomes 250 joule and potential energy becomes 750 joule. Yes, now let's go to third case. In third case, it keeps on falling. Yes, this stone keeps on falling, and by continuously falling, it reaches the ground. When it reaches the ground, its height will be 0, and its final velocity, we need to find out its final velocity. Okay, its final velocity will be v equals to u plus 80. Sorry, p equals to u plus 80. Okay, what is the value of u? Initial velocity is 0. Yes, plus acceleration was 10. Okay, and time. Okay, we do not have time, do we? No, we do not have time, so we cannot use this formula. We need to use another formula which contains both v and s. That means we need to use the formula v square equals to u square plus 2as. Okay, don't tell me that you have already forgotten Subat. Okay, you studied about Subat in your second lesson, if you remember. Okay, if you don't remember, I suggest you to go back to that lesson. Okay, you need to find v square. You do not know v. Initial velocity is 0 square plus 2 multiplied value of acceleration is 10 multiplied, and distance is overall height is 20. So when it falls up to here, it has already covered 20 meter of distance, isn't it? So v square equals to u square plus 2as, and it finally gives us v square is equals to 2 times 20 times 2, 40, 40 times 10, 400. Okay, and therefore by taking square root on both sides, you get 20 meter per second. Okay, so when the stone reaches here, when the stone reaches the ground, by what velocity will it strike the ground? It will be 20 meter per second, isn't it? It will be 20 meter per second. That means now we need to calculate its potential energy and kinetic energy once again when it reaches the ground. Okay, now look here, when it reaches the ground, the height will be 0. Okay, that means its overall potential energy will be 0 joule, whereas in case of kinetic energy, it has gained velocity of 20 meter per second. So it will be like 400, 20 times 20, 400, 400 divided by 2, 200, 200 times 5, 1000. Okay, it gives us 1000 joule. Okay, what we can observe here with this numerical. Okay, while doing this numerical, what we did observe is, okay, let me move it here. Here at this point it has 1000 joule of potential energy, but no kinetic energy, 0 joule of kinetic energy. When it reaches at this position, it has 750 joule of potential energy, and it has gained 250 joule of kinetic energy. You can see here its potential energy is decreasing from 1000 to 750, and its kinetic energy is increasing from 0 to 250. And when the object reaches the ground, its potential energy becomes 0, whereas kinetic energy becomes 1000. So in overall, its kinetic energy is increasing and potential energy is decreasing. Understood? So what's happening here, you can see that in overall the total energy processed by the object remains constant, and that total energy is known as mechanical energy, and mechanical energy is the sum of kinetic energy and potential energy. Okay, so in this case mechanical energy is equals to 1000 joule, isn't it? And in second case as well, look at the second case. Okay, look at your second case. And second case as well, mechanical energy, total energy, it has 250 joule of kinetic energy, whereas 750 joule of potential energy. So its total energy is still 1000 joule. Okay, its total energy remains 1000 joule, and at the end of motion, you can see here it has 1000 joule kinetic energy and 0 joule potential energy. So once again its total energy remains the same, 1000 joule. Okay, what I'm trying to tell you here is the energy simply transforms from one form to another form. Here it has potential energy, and that potential energy keeps on changing in kinetic energy until all the potential energy possessed by the object becomes kinetic energy. Okay, and the total energy possessed by the system, that is known as mechanical energy. So mechanical energy is also defined as the sum of kinetic and potential energy. Is you can take the note now, is defined as the sum of kinetic energy and potential energy possessed by the object. Okay, so ME is equals to KE plus PE. Okay, any confusion up to here? I hope you do understand this concept. Okay, then if so, you are to perform some numericals. I'll give you the question. Okay, you can conduct a numerical on your own. These are not very hard numericals. Okay, question number 1. Calculate the kinetic energy of a body of mass 2 kg moving with the velocity of 4 meter per second. Well, I think you can do this one. Yes, you are required to find out kinetic energy. Okay, mass is 2 kg and velocity is 4 meter per second, and you know the formula of kinetic energy, it is 1 by 2 mv square. Yes, mass is already given, velocity is already given. Simply substitute the value. Okay, and the second question, calculate the potential energy processed by a body of mass 50 kg lifted up to the height of 5 meter. Okay, now in this question you need to calculate potential energy. Yes, formula of potential energy is mgh, isn't it? mass is given m, okay, and up to height of 5 meter, this is height is given h, and the value of g you already know it, 9.8 meter per second square. And to make the calculations easier, you can use 10 as well, okay. And what will be the kinetic energy of the body if the velocity is doubled? Okay, this one you have to do on your own, okay. Hint, what you can do is, I'll tell you the easier way to do this question. What you do, let us suppose v is equals to x meter per second, okay. Just assume that v equals x meter per second. Then in second case, v becomes, you are told to double the velocity, isn't it? So v becomes 2x meter per second, okay. Use these values and then calculate, okay. It is very easy, it is not so difficult. Yes, okay. These two questions are your assignment, yes, home assignment, okay. Now let's go to next topic, and our next topic is other forms of energy, okay. Just now we discussed about forms of energy based on, okay, based on simple mechanics, isn't it? We discussed about the forms of energy based on simple mechanics, but there are other forms of energy in our practical life, yes. And what are these other forms of energy? Make a list of them. Make a list of them. Number 1, okay, heat energy, okay. Number 2, light energy. Number 3, sound energy. These three forms of energy we very commonly encounter in our daily life, okay. And other forms of energy are number 4, okay. What we have taken in number 4 is magnetic energy, yes, okay, magnetic energy. And number 5, electrical energy. These two are quite related. And then number 6, chemical energy. And number 7, nuclear energy, okay. These are 7 types of energy, or 7 forms of energy we will be discussing, okay. The first one is, definitely it is heat energy, yes. Number 1, heat energy, okay. You know that heat energy is, you studied it in grade 8 also. It is the form of energy that gives us sensation of warmth, isn't it? That is heat energy, the form of energy that gives us sensation of warmth. And in terms of kinetic energy, it is total sum of kinetic energy present in all the molecules of a body. That means when molecules vibrate, they produce heat energy, okay. That is, when molecules vibrate, they generate heat energy. So heat energy is also a form of kinetic energy, okay. Heat energy is also a form of kinetic energy, don't forget that, okay. And some of the examples of sources of heat energy you can quite easily tell, like fire, yes, the sun, and then friction, okay, and some chemical reactions, okay. These are the examples, okay, which provide us heat energy: fire, sun, friction, chemical energy. Okay, look at the picture. It is such a burning fire, isn't it? Does it afraid you? No? Well, you should be afraid of it. Okay, fire is very dangerous form of energy, isn't it? Okay, now the second one is light energy. Yes, you can see in the picture what is shown here, a light bulb, isn't it? Number 2, light energy. Okay, control B. Okay, light energy. How do you define light energy? It is a form of energy that gives us sensation of, vision. Okay, light energy is a form of energy that gives us sensation of vision. Okay, it is formed due to fast moving photon particles. Okay, this might be a new word for you. You have studied 3 types of particles. These are proton, electron, and neutron. But remember, in universe, these 3 are not the only type of particles. These 3 are not alone. There are other particles as well. However, proton, neutron, and electron are the particles that forms most of the part of the universe. But there are other particles as well, and photon is one of them. Okay, when photon moves very fast, it produces the form of energy, light energy. Okay, when photon moves very fast, it forms light energy. Yes. Okay, so it is formed due to fast moving photon particles. You can say it is also a form of kinetic energy, just like heat energy, isn't it? Just like heat energy, it is also a form of kinetic energy, because it is also formed by motion. Okay, by what? Fast moving photon particles. When photon particles move, it forms light energy, means it is formed due to motion. So light energy is also a form of kinetic energy. And some of the examples producing light energies: the sun, you know that. Okay, electric lighting devices, okay, such as electric bulb, tube lights, CFL. Yes, LED. Yes, there are so many examples. Okay, let me write it: LED, CFL, LCD, your LCD monitors, isn't it? And then tube lights, etc. Okay, electric lighting devices, and then chemical reactions. Okay, have you seen firefly? जुनकिरी को पछाडि पट्टि बत्ती बल्छ है। त्यो बत्ती भनेको आगो होइन। जुनकिरीले एक किसिमको प्रोटिन बनाउँछ, उसको एब्डोमेनको टर्मिनल पोर्सनबाट एउटा प्रोटिन बनाउँछ। त्यो प्रोटिनलाई हामी के भन्छौँ त? लुसिफेरन्स भन्छौँ है, लुसिफेरन्स भन्छौँ। यो लुसिफेरन जब एयरमा आइपुग्छ, हावामा आइपुग्छ, तब यसले अक्सिजनसँग रियाक्सन गरेर सर्टेन प्रडक्ट बनाउँछ। ओके, र यो प्रोसेसमा के हुन्छ त? लाइट इज प्रोड्युस्ड इन दिस प्रोसेस। ओके, लाइट इज प्रोड्युस्ड ड्यू टु द रियाक्सन अफ लुसिफेरन्स एन्ड अक्सिजन। कसको केसमा त? इन केस अफ फायरफ्लाइज। फायरफ्लाइको केसमा उनीहरूले लुसिफेरन भन्ने प्रोटिन बनाउँछ, जसले अक्सिजनसँग रियाक्सन गरेर लाइट प्रोड्युस गर्छ। भनेपछि यो केसमा लाइट केले गर्दा प्रोड्युस भयो त? केमिकल रियाक्सनले गर्दाखेरि लाइट जेनेरेट भयो है। त्यस्तै अब अर्को, नाउ लेट्स गो टु नेक्स्ट वान। दिस वान इज साउन्ड एनर्जी। नम्बर 3, साउन्ड energy. Does it look like sound? Well, it may not look like sound to you. Okay, it may not look like sound to you, but it is sound. Okay, but it is sound. In what sense? This is the wave representation of sound. Okay, this is a wave representation of sound. We cannot see sound, but sound energy follows a certain path that is called wave. Okay, now sound energy, it is the form of energy that gives us sensation of hearing. Okay, it is produced due to vibration of particles. Okay, now look here, heat energy is also produced by vibration of particles. Yes, when molecules vibrate they generate heat energy, and sound energy is also produced in the same manner. That is why sound producing devices usually produce heat as well. Okay, sound producing devices usually produce heat energy as well. Okay, due to vibration of particles. Okay, some examples of sound producing devices are particles or membrane. Okay, some examples like drum. Okay, drum produces sound energy by vibrating membrane. Okay, and flute or whistle, trumpet. Okay, these devices produce sound by vibrating air molecules. Okay, and drum, speakers. A speaker also has vibrating membrane. Okay, they want to see the structure of speaker. If yes, we can find structure of speaker. Okay, speaker structure. Okay, let's find out the simplest structure over here. Okay, this picture is clear, I guess. Okay, in this picture you can see this is the vibrating membrane. Yes, this hole is a cone. This whole cone is a vibrating membrane. Okay, and due to generation of magnetic energy over here in magnetic field, production of magnetic field, these membranes start to vibrate. While you play your speaker, please toss the membrane. Okay, you can feel the vibration. Look here, this okay, this is the GIF. Okay, showing the vibration of speaker and production of sound, and this vibrating membrane is called diaphragm. Okay, this is called diaphragm. Look, this is vibrating. Okay, because of vibration of this membrane, sound is being produced in a speaker. Okay, now okay, etc. Let's go to next form of energy. Okay, they need revising. Once again, go over here. Number 1, heat energy. Pause the screen, take the note. Number 2, light energy. Number 3, sound energy. Okay, now number 4 is magnetic energy. Okay, magnetic energy, it is the form of energy processed by magnets, due to which like poles repel and unlike poles attract. Okay, a magnet. Okay, magnet has north pole and south pole. If you try to bring north pole of one magnet to north pole of another magnet, they move away, isn't it? But if you try to bring north pole of one magnet to south pole of another magnet, they come closer to each other. Yes, they come closer to each other. Okay, that force, that force is due to the magnetic energy. Okay, that force is due to the magnetic energy. Okay, and a magnet possesses magnetic energy is due to spinning of electrons. It is the phenomenon of spinning of electrons in an atom. So all atoms has electrons. All electrons are a tiny magnet, means all atoms have magnetic properties. So all objects have magnetic properties, but since electrons occur in pair and the electrons in pair spin in opposite direction, they cancel out magnetic properties of each other, magnetic field of each other. Okay, and in most of the atoms and molecules, electrons exist in pair, so their magnetic properties are being cancelled, and we cannot experience magnetism in everything. However, elements some special elements or substances have unpaired electrons, unpaired stable electrons. Okay, unpaired stable electrons whose magnetic field is not cancelled by any other. Okay, and such substances are used as magnets. Yes, example: horseshoe magnet, bar magnet, ring magnet, etc. And note this also: iron, cobalt and nickel are only natural materials that are magnetic in nature, are magnetic elements. Okay, these are. Now see, here I gave you this picture as a bonus. This is a picture of a generator, okay, which produces electricity. A generator which this is the internal structure of a generator which produces electricity. Here what you can see, it contains a piece of magnet, yes, and then kept in such a way that north pole of one magnet and south pole of another magnet are facing each other, so there is a magnetic field, okay, originating from north pole to south pole, and in that magnetic field a coil is placed. Yes, a coil is placed, and that coil is connected to two slippers. Okay, and the coil has a handle. Okay, you can rotate the coil by using this handle, and when you rotate the coil, it generates electricity. Okay, here wire is not seen here because the color of wire is black and the background is also black. That's why you cannot see the wire in this picture. Anyway, the generated electricity passes through this wire. This phenomenon is known as electromagnetic induction, which was discovered by Michael Faraday. Okay, so what I'm trying to show here is electrical energy or electricity is produced due to magnetic energy. Magnetic energy and electric energy, they are interconvertible. You can convert electrical energy into magnetic energy, okay, as well as you can convert magnetic energy into electrical energy. Yes, all generators used in our home and in our hydropower station, okay, in windmill, everywhere the generators are used, whose basic structure is this. This is the basic structure of all the generators which are used in the world. Okay, now let's go to next form of energy, number 5. Okay, by seeing the picture, you know what I am going to tell you. It is electrical energy. Okay, you know what is electrical energy? We just discussed about it, isn't it? Okay, it is the form of energy possessed by an object due to flow of electrons, okay, or you can say continuous flow of electrons, or change in concentration of charges. Charges means positive charge and negative charge. Okay, and positive charge is protons have positive charge and electrons have negative charge. You all know this, yes? And if an atom has equal number of proton and electron, then it does not have any charge, okay? But if an atom has higher number of electrons than proton, then it will have negative charge. And if an atom has lower number of electrons than proton, then it will have positive charge, okay? Now when the electrons freed from the atoms, electrons are freed from atoms, and these electrons run through certain conductor medium, then they possess electrical energy, okay? And this form of energy is very familiar to us because many electrical devices such as bell, okay, and lamp, heater, as well as electronic devices, electric and electronic are different, okay, such as mobiles, TV, radios, computers, etc., operate with electrical energy. It is produced by generator or dynamo or cell, okay? Cell means battery. Generator, dynamo or cells are the sources of electrical energy. If you need to take note, pause the screen and start taking note, okay? This is the electrical energy, okay? And now next one, a very important one, it is what is the number? 5, 6, okay. Number 6, it is chemical energy, okay? Chemical energy, the energy stored in chemical bonding of substances which can be released in the form of heat energy are called chemical energy, okay? Let's say for example, let's take an example. Okay, this is hydrogen molecule, okay? This is hydrogen molecule, yes? And there is another hydrogen molecule as well, okay? And there is an oxygen molecule, okay? So what happens is hydrogen and oxygen, hydrogen has one electron in its orbit, okay? You will study this in detail in chemistry section. Oxygen has 6 electrons, and to be in octet state, oxygen needs 2 more electrons, so it forms chemical bonding with hydrogen on 2 sides. There is some kind of force that keeps attracting hydrogen to oxygen and another hydrogen to oxygen. Here, these force of attractions that bind atoms to form molecule, they are called chemical bonding. So since these are force of attraction, they definitely possess energy, and that energy is known as chemical energy, okay? That energy is known as chemical energy. So every single object has chemical energy. Your the paper, your hand, okay, your food, okay? So example, paper, wood, food, meat, whatever you say, everything contains chemical energy, but only from certain substances chemical energy can be released, okay? And these substances are considered as fuel, yes, fuel. For example, petroleum diesel, kerosene, LPG gas, firewood, okay, or paper that you can burn. Yes, hay means paral. Okay, so these things, or cow dung. Yes, okay. Let's add an example. Cow dung, because in our rural areas in our country, cow dung is also an important source of important source of fuel, isn't it? Okay, so the chemical energy, it is the energy, remember this, energy stored in chemical bonding of substance. Okay, chemical bonding of substance, which can be released in the form of heat energy. Okay, that is called chemical energy. And look at the example over here. We are given coal, okay, the burning coal, and another example here how chemical energy comes to existence. Okay, it shows how chemical energy comes to exist. Okay, here sun provides solar energy, isn't it, in the form of heat and light energy, which is captured by plants and make food. That food produced by plant contains chemical energy. Okay, the part of plants are used as firewood. Yes, and so firewood also contains chemical energy, and when we burn the firewood, the chemical energy is converted to heat energy. Okay, okay, and let's go to the last topic for today, nuclear energy. Number 7, nuclear energy. Okay, what is nuclear energy? The energy that is present at the nucleus of an atom, isn't it, which can be released during nuclear reaction. Okay, this is called nuclear energy. Okay, and what does it mean? And once again, look here, this is an atom. Yes, and what does an atom contains? Okay, nucleus of atom contains proton plus neutrons. Okay, nucleus of atom contains proton plus neutrons. Yes, now you know that in nature positive and negative attract each other, and proton has positive charge, okay, whereas neutron does not have any charge, it is neutral. Neutron does not have any charge, it is neutral. So what attracts proton and neutron? Actually, what attracts proton and neutron? The answer is nothing. Nothing attracts proton and neutron. They don't have opposite charge. Then how is it possible that several number of protons and neutrons are condensed inside the nucleus of an atom? How is it possible? If they do not have opposite charge, then how is it possible that they attract each other? How is it possible? There is any possibility? Well, I don't see any possibility here. Okay, the protons and neutrons, they do not attract each other. Moreover, to make the matter worse, since protons have positive charge, all protons have positive charge, they repel each other. The protons repel each other. So how is it possible that they all are congested in a nucleus in such a small confined space? Okay, so there is a kind of force which holds them together in nucleus. Okay, there is immense amount of force which holds them together in nucleus. Okay, immense amount of force holding protons and neutrons in nucleus. Okay, and that force is known as what? Nuclear energy. That is nuclear energy. Okay, and so you can say every single object has nuclear energy, because all objects are made up of atoms and all atoms have nucleus. So every single object has nuclear energy, but most of the atoms are already in stable form. That means you cannot separate protons from them, so the nuclear energy cannot be released. Okay, so the pen you are holding in your hand also contains nuclear energy, but you cannot release that nuclear energy. Okay, however, there are certain elements in nature. Okay, there are certain elements in nature whose nucleus are highly unstable. Okay, such as uranium, radium, barium, francium. Okay, let me write, etc. Okay, these are some of the elements that are whose nucleus are highly unstable, and they tend to break off. When their nucleus break off, they release the nuclear energy holding their protons, and that nuclear energy can be harvested in the form of heat energy and then electrical energy. We will discuss that. Okay, now there are two types of nuclear reaction. Nuclear reactions are two types: nuclear fission reaction and nuclear fusion reaction. Okay, in the first example you can see it is the nuclear fission plant. Okay, or nuclear reactor, also called nuclear reactor. Control J E. Okay, here you can see these are all the chimneys. Okay, this is the largest structure you can see, but this is not the main structure. Main structure is at the base. Okay, these are just the chimneys, and this is not smoke. This is not smoke. This is water vapor. Okay, this is water vapor rising from there. Now the internal structure of the nuclear plant is somewhat like this. Okay, it contains three units. One is nuclear reactor. Okay, the nuclear reactor, and then here you can see the turbine. Okay, here is condenser. Yes, and this is cooling tower. Okay, the structure you are seeing here, these are cooling towers. This is cooling tower. Here a nuclear reactor, I got this image from Encyclopedia Britannica. The nuclear reactor contains the core. Okay, the core contains radioactive elements. Okay, the core contains radioactive elements. Yes, and these radioactive elements generate large amount of heat energy. Okay, and that heat energy is absorbed by water present in this chamber. Okay, the water in this chamber is heated at very high temperature, and that water passes through here. You can see this tube. Yes, that water passes through here, and this is called steam generator. Okay, this steam generator also contains water. Okay, it absorbs heat energy from water inside this coil. Okay, because of that heat, the water in the steam generator evaporates and they form steam. Okay, whereas water inside the coil cools down because their heat energy is absorbed by water out here. Okay, and that water is pumped back into core, and here in steam generator, the generated steam is passed through tube at very high pressure. Okay, and that high pressure steam is incidented on turbine. Because of the pressure of steam, the turbine rotates. Okay, the turbine rotates. That turbine is connected to electric generator, and you know when turbine is rotated, it produces electricity, okay, that is fed into transmission line. And afterwards, rotating the turbine, the steam is passed through here into condenser, okay. In the condenser you can see there is another pipeline through which from here cool water comes, okay. Cold water comes. That cold water absorbs heat energy from the steam, okay. That cold water absorbs heat energy from steam, and the water becomes vaporized. Water vaporized, and what the steam in here condenses back to cold water that is pumped by water pump into steam generator again. And the steam produced here moves into the cooling tower, okay, where because of cooling the water vapor or steam again changes, condenses back to water, okay. That water is collected here, okay. However, in this process, maximum amount of water vapor, instead of condensing, they gets released into air, okay. That's why the reactor continuously needs to feed water in this cooling tower, okay. That water is intake from lake or river, okay. Do you understand the plant or not? Yes, I hope you do understand it, okay. And the reaction is like this. See, this is a uranium nucleus, and these pink balls are protons, white balls are neutrons. A uranium nucleus has atomic mass of 235 and atomic number of 92. When a neutron collides, it forms heavy uranium, okay, isotope of uranium, which contains whose atomic mass is 236. Atomic number remains the same, and this is highly unstable, that instantly breaks down to form two nucleus, okay. First nucleus is krypton with 36 protons, and second nucleus is barium with 56 protons. They take the amount of neutrons which are necessary to make their nucleus stable, okay. However, 3 neutron particles are released in this process, okay. These 3 neutron particles further bombard 3 other uranium and causes the reaction to continue, okay. This is the nuclear fission reaction. What is this? Okay, yes, you are right, this is nuclear fission reaction, the reaction in which a heavy and unstable nucleus of an atom breaks down to form 2 or more lighter, stable nuclei, okay. This is nuclear fission reaction, okay. Now let's go to next one here. This is nuclear fusion reaction, okay. Nuclear fusion reaction mainly takes place in star and other sun and other stars. Sun and stars have very high number of hydrogen. You know that when 2 hydrogens collide, okay, they release energy, okay. They release this is what okay, I forgot the name of this part, okay. Yes, positron. They release positron particle, and one of the proton becomes neutron, okay. You know that hydrogen nucleus of hydrogen contains only 1 proton. When 2 protons collide, one of the proton becomes neutron, okay, and it forms deuterium, okay. Deuterium again collide with another hydrogen to form light helium, okay, and 2 atoms of light helium combine to form heavy helium, okay. That's how helium is formed, and hydrogen is depleted from sun, and during this reaction also energy is produced, okay. We are running out of time, okay. Let nuclear fusion reaction is the reaction in which 2 or more light nuclei combine to form heavy single nucleus. Okay, and it takes place in sun. Okay, this much for today. Okay, in tomorrow's class we will discuss about conservation of energy and power. Okay, until then, bye bye for today. Okay, see you tomorrow, kids.